Hello, my name is Cassandra Baque, and this is demonstration for, Daniel Baque, whatever, Cassie Baque, whatever. So this is the first demonstration that was essentially asking us to conduct the hypothesis, the null hypothesis, and then the approximate, or the alternative hypothesis, and then critical values, etc., etc. So here you can see I list like the values that we were given, the percentages of the United States, Canada, Europe, and the miscellaneous ones, or elsewhere, as it puts it. And essentially from there, we're kind of just doing it. Look, right here, we identify the null hypothesis of H, and then right after that, pretty much after we have that, we can just go on and do our test values and looking for expected frequencies, because here we have the equation of the cheese squared statistic. So what we'll call it, pretty much we're just doing the expected frequencies, which is just multiplying the numbers of the United States, like 460 times 0.75 equals 115. Canada, 460 times 0.35, which is the percentages, by the way, because this was 25%, then 35%, so you just write it as a decimal. So it equals 161. Europe is 460 times 0.30 equals 138, and then miscellaneous is 460 times 0.10 equals 46. So pretty much we just plug this into the equation that we have right here, and the cheese squared statistic, and then we can pretty much just get all the values. So you see I plug it in here, so it becomes 150 minus 115 squared over 115, which gets us approximately 10.61. And then Canada, you do the same thing. Here I get approximately 4.53. Europe, same thing. You can see I do 156 minus 138 squared divided by 134 equals 2.35. And then miscellaneous, we get the approximate value of, the approximate value of 14.20. Okay, so after that, we're figuring out the the critical values with the two-tailed thing, which is the df equals n minus 1. So here we do df equals 4 minus 1, which is approximately 3. So pretty much, given that, I would like to add that x squared, once we get all the values, I totally forgot to mention this, that you add all the approximate values that we got to get 32.19. But pretty much with x squared critical, we get 6.251, which pretty much just proves these two values right here prove that we are rejecting the null hypothesis. But that's question 1. Okay. Okay, dope. Now on to number 2, which is where we're taking steps. So first here in A, we're using the we're trying to figure out R, which is the correlation coefficient. So here we have the equation, n sigma xy minus sigma x sigma y under the square root n sigma x squared and multiply that by n sigma y squared minus parentheses sigma y squared. Okay, so pretty much here we're just counting up all the sums of the data we're given. So like here we can see that sigma squared equals 144, sigma y is 35.1, sigma xy is 86.81, sigma x squared 3614, and then sigma y squared is 210.15, I think that is. I don't know, my handwriting's kind of shoddy, but I wrote that down. And then here we're doing the two-tailed thing to get t, which is t equals r square root of n minus 2, and then over square root of 1 minus number 2. So from here, pretty much this is part B, by the way. So we plug it in. This is very simple. It's just t equal, oh my god, wait, I totally forgot about part A. I didn't even talk about plugging in the equation, but we plugged in the entire equation, 6 times 868.1 minus 144 times 35.1 over all of this to get the approximate value of 1.00. So r equals 1.00, so that's where we plug it in here. So now to go on to this, t equals 1.00, x, the square root of 6 minus 2 over the square root of 1 minus 12. So whatchamacallit, pretty much from that we get 2 over 0, which is almost like a perfect correlation, or which it means, because it's like very statistically significant. So whatchamacallit, now we're figuring out the regression line, which is very simple, the y equals mx plus b equations, and we're just we're figuring out what the values of m and b are. You can see I have the equations here, and we're just plugging in the values, same as the other stuff. And with that, we're able to get the equation of y equals 0.162x plus 1955. And from there, it asks us to find the mood line, which essentially is just us plugging in the x value of 35. So you do y equals, which I have written down right here, y equals 0.162 times 35 plus 1.955, which equals 5.67 plus 19555, which equals 7.625. So it's roughly, or like approximately, like 7.63. We can round up. But yeah, that's question 2, and that's my demonstration 4. Thank you so much.